Simultaneous equations. Here are two simultaneous equations. If we look at just this first equation, equation number 1, it's got two unknowns in it. If that was all I had, 3x plus 4y equals 12, I couldn't solve it because I'd need to know one of them, y say, to be able to find x, and vice versa. However, it's true that if I have another equation involving x and y, assuming that they are the same values of x and y in both equations, then in theory I can solve it. If I had an equation with three unknowns in it, x, y and z, I would need three separate equations to be able to solve that. So long as I've got the same number of equations or more as number of unknowns I've got, I can solve them. And I do it in a couple of ways, either by substitution or by elimination. So simultaneous equations can be solved actually in three ways. Elimination, which if you've done any work on simultaneous equations will probably be the one that you're thinking of. Substitution, which is a more general algebraic method, and it's certainly something that you would use if the equations were more complex than just straightforward linear equations. In other words, I had powers involved. And finally, graphical, by plotting a graph and seeing where a graph of the first equation, a graph of the second equation, and seeing where they cross. Where they cross is the solution to the two equations. So if you've got access to a set of some software like Autograph, solving simultaneous equations is straightforward. You just put the equations in and see where the lines cross. And that's something you'll be doing in one of the assignments, the Unit 28 assignment. However, we also need to look at algebraic ways of solving simultaneous equations, elimination and substitution. We'll focus particularly on elimination today. So I would use elimination to do this, for example. So solution by elimination is what we'll look at. So solving by elimination. The idea of this is to look at the values of x and y in the two equations and make them the same. If I multiplied everything in equation 1 by, say, 3, so long as I multiplied every term by 3, so 3 lots of 3x is 9x, 3 lots of 4y is 12y, and 3 lots of 12 is 36, the equation would still be true. If I multiply one of the terms by something, so long as I multiply every term by it, it will be true. So what I do is I think of that and I think, okay, what can I multiply x or y by to get them the same? If you look at this, the obvious one is if I multiply 2y by 2, I'll get 4y, and then I'll have 4y in both of the equations, and that's the idea, that's what you do. So the first thing is just to look at them and think to yourself, how can I make x's or y's the same in both equations? So that's what we're going to do. And so I'd write down multiply, and I'll use a abbreviation like that, or I use the multiplication symbol, equation 2 by 2. And then I do that. I take each term in equation 2 and multiply it by 2. 10x minus 4y equals 20. And then I call that equation 3. We look at the situation and we can see where the elimination comes in. If I now rewrite equation number 1 underneath, which is 3x plus 4y equals 12, that's equation number 1, then we can see that because the y's are the same, in theory, we can eliminate them, hence the term elimination. If I added equation 1 to equation 3, I'd have 4y plus minus 4y would be 0. And now I just have to add the other terms as well. So what I do is I say equation 1 plus equation 3. 10x plus 3x is 13x. 4y plus minus 4y is nothing. Gone. And that's the aim. If it doesn't disappear at this point, you've made a mistake. Equals 20 plus 12 is 32. Now we've got an equation that involves only one unknown, and we can solve it. We can find x. We divide both sides by 13, and x equals, therefore, x equals 32 divided by 13, which is 2.46. Thank you. Is that exactly that? Right, so to 3 significant figures. Okay. So again, if we're going to round, give the accuracy, or write down the accuracy. Okay. So now we've got one of the values, x is 2.46. We now substitute this back into one of the original equations. So we substitute into 1. Substitute. That means substitute my value of x back into, doesn't matter which you choose, but let's say into equation number 1. So I rewrite number 1, but instead of x, I'm going to write what x is. So 3 times 2.46 plus 4y equals 12. It's good practice, I think, to put the number that you're substituting into a bracket rather than put times. And maybe as it gets more complex, the algebra that you're doing, you'll see why that's useful. But at the moment, you could just as easily put 3 times that. So now we've got that 7.38 plus 4y equals 12. What do we do now? Yep, subtract 7.38 from both sides. 4y equals, thank you, and then divide both sides by 4. Y equals, right, but we'll call it, say, 1.16 to 3 significant figures, because there's no point going to more significance than the other one. So you've got to be confident these two values, x and y, that we've calculated are correct. In an engineering situation, you've not got someone there to ask. You've got to know that that's right. What would you do? Work what out? What would you do? Yeah, put your values for x and y that we've just found out into the second one, the one we haven't used yet, and then see if you get the answer 10. You probably won't get exactly 10 because we've rounded our answers, but we should get near enough 10. So check in 2. Don't check in the one you've already used, because if you made a mistake, you might make the same mistake. So check in the other one. Check in 2. What is equation 2? 5x minus 2y equals 10. So 5x minus 2y equals 10. So in theory, 5 times our value for x, 2.46, minus 2 times 1.16 should give 10. Which it does, so we're now fairly confident that we've got the correct values for x and y.